Hi guys, my name is Arya and I'm from EduReka. Today I'm going to be talking to you all about Hyperledger. We're going to see what all the jazz behind Hyperledger is about, why exactly does it hold a certain amount of significance in today's IT industry, then I'm going to briefly demonstrate through a simplistic example as to how Hyperledger works, and then to conclude the video we're going to go through some of the few Hyperledger projects that have gone really famous over time. So without wasting much time, let's jump into today's video. Now, before I tell you what Hyperledger is, let me tell you what Hyperledger isn't, because it's really easy to get confused in today's world with so many blockchain platforms around. So firstly, Hyperledger is not a cryptocurrency that so many people seem to be interested in today's world. Above that, Hyperledger is not a blockchain, and neither is it a company. So what exactly is Hyperledger? Well, to begin with, Hyperledger is a project under the Linux Foundation. So like other projects under the Linux Foundation, for example, Node.js, Aljoin, DroneCode, and many more, Hyperledger is also an open source development project where people from all over the planet can come and help Hyperledger get developed as a software and as a platform. Now, according to the executive director of Hyperledger, Brian Behlendorf, Hyperledger is an open source community of communities to benefit an ecosystem of Hyperledger-based solution providers and users focused on blockchain-related use cases that will work across a variety of industrial sectors. So what exactly does that mean? Well, in simpler terms and analogies, Hyperledger can be thought of as a software that enables developers all across the globe to develop blockchain-based solutions for their particular businesses. At this point, some of you who are slightly versed with the blockchain technology might be thinking that, hey, we have platforms like Ethereum. Why can't they do what Hyperledger does? Well, the ethos of Hyperledger is that it believes every business or industry is unique in its own ways, and applications tending to that service must be personalized, unlike the Ethereum blockchain, which runs on a very generalized protocol for everything that runs on its network. You will see what I mean in a short while. Now, let me give you a brief history about Hyperledger before delving deeper into its mechanics. So first of all, Hyperledger began as a small project by a limited number of developers who came from various sectors like finance, supply, and data management. All these people had one common goal in mind, and that is to make the blockchain as a technology more accessible to the world. So with these things in mind, developers started testing the interactions between applications and secure blockchain networks. While rigorous testing between the two, developers involved realized that public blockchains that require each peer to execute each and every transaction and run consensus at the same time too takes a huge blow when it comes to scalability, as the network takes a really exhaustive measure to ensure security. Above that, any transaction that has a measure of confidentiality and privacy attached to it cannot be executed on the blockchain due to its public nature, as every ledger on the network will get updated and confidentiality is lost. To understand the concept of a private and confidential contract, let's look at a simplistic example. Let's say Bob in India wants to buy chocolates from his friend Alice, who lives in Switzerland. As they were old friends, Alice decides to sell Bob her chocolates at a pretty generous discount. But the catch here is that Alice also supplies to a number of different markets, which still need to buy chocolates from her at the standard rate. Above that, to actually get her chocolates from Switzerland to India, there are a number of procedures to fulfill. For example, firstly, she sends her chocolates to the mailing service, which in turn validates the supply. After a product is packed and sealed, logistic verification takes place. After that, during shipping, distribution logic is verified and validated, and in the end, payment verification is done before the package finally reaches Bob. But the point here is that even though there are so many third parties involved in the transaction, they do not need to know about Alice's and Bob's special deal. Now, when this whole transaction is run on a public blockchain network, where every peer has to go through every transaction, confidentiality of the deal becomes void, and every single ledger on the network gets updated about Alice's and Bob's special deal. This is where Hyperledger comes and wins the game. On a Hyperledger-based network, the parties who are directly affiliated with the deal are connected. The ledgers that get updated about the special deal are only Alice and Bob, thus maintaining the private and confidential aspect of the contract. Let's see how Hyperledger actually pulls this off. It all starts with Alice looking up Bob through an app, which in return sends the query to a membership service, and sends the transaction only to the peers directly affiliated. Both the parties now will generate a result. In this two-party agreement, both results generated need to be the same for it to get validated. But in other transactions, where there are multiple different parties, other rules can also be applied as needed. The validated transactions are then sent to a consensus cloud for ordering, These ordered transactions are sent back to the affiliated peers and then committed to their ledgers. This same pattern of a transaction is needed by multiple industries, where private and confidential obligations are need to be met by multiple parties without processing everything through a single centralized authority. Now that I've told you what Hyperledger is, how it pulls off a permissioned blockchain network, let's go through the architectural changes that make this all possible. The most notable changes can be seen in the peers, which make up the whole network. The peers are separated into two different runtimes and three distinct roles, namely endorsers, committers, and consenters. While endorsers and committer peers are executed on the same runtime, the consenter peers are run on a completely separate runtime. This allows Hyperledger's modular architecture to allow properties like consensus to be a plug-and-play feature, which in return allows a high degree of personalization to the network according to the needs of the business. Now, let us go over the peer roles. Firstly, the peer role we are going to discuss is that of a committer. The most simplistic role is that of a committer node. Their only role is to append validated and ordered transactions to the specific ledger once returned by the consenters. Normally, a committer can work as an endorser on the same network, but as more and more restrictions are imposed on the network, the merging of endorsers and committers are completely avoided. The second role is that of an endorser. These nodes simulate the transactions pertaining to the network and also prevent the occurrences of non-deterministic and unstable transactions. It is important to note that while committers may or may not be endorsers depending on the network restrictions, all endorsers act as committers on a Hyperledger network. Lastly, we have the consenters, which work on a different runtime. These nodes are responsible for running the consensus algorithm on a network and can be very well thought of as the bodyguard of the network who validates every transaction, deciding whether or not it should be added to a ledger. Now that we know what Hyperledger is, where it's necessary, and how it works, let's compare Hyperledger to the two most renowned blockchain networks, and that is Bitcoin and Ethereum. Starting with cryptocurrencies, while Bitcoin and Ethereum both have their respective currencies, Hyperledger has no official coin. But if a business deems necessary that they need a coin for themselves, they can always implement one. Moving on to networks, Bitcoin and Ethereum are both highly public blockchain networks. Hyperledger, on the other hand, is a consortium blockchain, which is also known as a permission network. Talking about consensus algorithms, Bitcoin uses SHA-256, which stands for Secure Hashing Algorithm 256, and Ethereum uses another hashing algorithm called ethash. Erstwhile, Hyperledger uses a completely new concept called practical fault Byzantine tolerance, which basically checks how much time a transaction has resided on a machine. Bitcoin has no support for smart contracts or any sort of business logic for that matter. On the other hand, Ethereum and Hyperledger both support smart contracts. Ethereum smart contracts are mostly written in Solidity, while Hyperledger smart contracts are written in chain code. On the topic of the language each network is written in, Bitcoin is written in C++, while Ethereum and Hyperledger use a mix of Golang along with Python or Java respectively. Talking about projects under Hyperledger, there are a few noteworthy ones, like Hyperledger Fabric and Sawtooth. Hyperledger Fabric is being extensively used in the supply chains and market networks, and Sawtooth has seen success in the fishing industry. There's also Hyperledger Iroha, which is used for developing blockchain-based mobile applications. Another project, Hyperledger Indy, is used for decentralized identification databases for business networks.